This video explains ExPLoRe, Expert Patch Level Loss Routing for Multi-Objective Masked Image Modeling. The paper's main claim is simple. Different image patches should receive different objective weights during self-supervised pretraining. Multi-objective MIM combines token distillation, CLS alignment, and pixel reconstruction. But most methods use global scalar weights for these losses. That ignores spatial heterogeneity, because patches containing object structure and background texture likely need different training emphasis. ExPLoRe repurposes Soft-MoE dispatch weights as per patch loss coefficients. The same routing logics that decide expert interaction now also modulate objective contributions at patch level. So routing becomes not only computation allocation, but also supervision allocation. The central mechanism is loss coupling. Gradients from objective terms are allowed to flow through dispatch weights into router parameters. Detach ablation blocks this path and drops performance, showing that coupling is the main driver rather than static reweighting. Architecturally, Soft-MoE is integrated into a VIT student encoder. The framework learns shared logics, then derives dispatch and combine weights used for expert aggregation and loss modulation. Teacher features provide semantic targets, as in distillation-based MIM. The paper studies two objective bundles, token plus CLS and token plus pixel. Routing can weight each objective differently per patch, but sparse encoding constraints mean some choices interact with masking visibility. That design detail affects where MoE gains are strongest. MoE design ablations tune entropy regularization and routing placement. Results show the method is sensitive to entropy weight, especially as expert count grows. So regularization must be treated as scale-dependent, not a one-size parameter. Expert scaling analysis is a strong part of the paper. Token plus CLS scales smoothly up to 64 experts, while token plus pixel peaks earlier around 32 experts. This indicates objective-specific capacity scaling behavior. For downstream adaptation, the authors propose practical recipes: freeze routing, expert dropout, and freeze attention. These stabilize fine-tuning and recover transfer performance that naive MoE adaptation can lose. The recipe contributes nearly as much as the pretraining innovation in some settings. On ImageNet 1K with VIT base, ExPLoRe improves over non-MoE baselines on both objective combinations. Reported gains include plus 0.5 KNN for token plus CLS, plus 2.2 for token plus pixel, and strong linear probe and fine-tune accuracy. The comparison table also reports efficiency through GFLOP metrics and adaptation quality. The paper positions ExPLoRe as a practical trade-off. Modest overhead for better representation quality and stronger transfer when using the adaptation recipe. A notable downstream result is on ADE20K segmentation. With the proposed adaptation strategy, MoE models close a substantial MIOU gap and can match or exceed non-MoE baselines. That addresses a common criticism that MoE pretraining helps only classification metrics. Conceptually, ExPLoRe treats routing as an information bottleneck that allocates supervision where it is most useful. Patches that encode semantic identity may get stronger token or CLS pressure, while texture-heavy regions may receive different emphasis. This creates an emergent division of labor across both experts and objectives. Limitations remain. The method introduces additional hyperparameters, expert count-dependent regularization, and adaptation complexity. Future work should reduce recipe sensitivity and test whether similar loss routing extends cleanly to larger backbones and multimodal objectives. Final takeaway: ExPLoRe shows that patch-level objective routing is a powerful upgrade for multi-objective masked image modeling. By coupling losses through dispatch gradients, it turns a static weighting problem into a learned spatial allocation mechanism. If you work on self-supervised vision with multiple objectives, this is a highly actionable idea.